Can you give us maybe 3 ways in which human brains and the current crop of large language models and our thinking are similar, and maybe 3 ways in which they're fundamentally different? Is that a bit too
I'll give you some ways of each. Yeah, I can't promise what. Yeah. So what's similar? I mean, I think, structurally, there are similarities and differences, right? So if you think about the structure, so the brain is fundamentally a neural network, and the architectures which, power modern deep learning are neural networks. So, neural networks consist of like sets of units which encode, they encode values, which in the brain is sort of like how much activity is being generated, and in a neural network, artificial neural network is just a number. And those units are connected together by connections that have variable strength. And in neural networks, those are weights, and those weights are, again, just numbers that dictate those strengths. And in the brain, they're synapses, and there are a number of factors that dictate synaptic efficacy, but broadly they boil down to various forms, like how many receptors there are and how vigorously they're released, right? Which is determined by various protein synthesis mechanisms. So there's a structural similarity. But there's also a big structural difference, which is that, if you think about the way that particularly transformer networks, which are the sort of the workhorse of modern deep learning, particularly large language models, the way they work and the way the brain works, like the dynamics of activity are incredibly different. So, transformers, what they do broadly is they take some information, they sort of very cleverly learn kind of like what goes with what. So the weights are sort of roughly encoding some sense of what goes with what, and then they make a prediction about the next thing. So through the network, there's just one sweep of information, input through to output. The brain is not like that. The brain is recurrent. So what that recurrence means is that their patterns of activity in neural networks become like they display interesting dynamics. They are self-sustaining in many ways. So, neurons will excite neurons that will excite other neurons that will excite those first neurons in the first. And so you get these loops of activation. So from a physical standpoint, there are both similarities and differences. And I think, from when you look at a behavioral standpoint, you can also see similarities and differences. So much of the similarity, I think, is in the fact that although the brain is a neural network, which is kind of messy and entangled and has these weird kind of dynamics, it's able to engage in very, very, very structured forms of reasoning. So it's able to retrieve knowledge and make logical inferences, like, kind of knowing, for example, that if A is greater than B and B is greater than C, then you know for free that A is greater than C, right? That type of inference, which is called transitive inference, that type of inference is something which you can't just memorize it because nobody ever told you about the difference between A and C. You have to infer it from the data. And sort of magically, even though the brain is a mess, what comes out is highly structured and sensible. And neural networks is exactly the same, right? So despite the fact that the GPT-4 or your favorite language model has millions of parameters, nobody understands what's going on inside it. And yet, like, what you get out is these very structured forms of behavior. So there's a lot of similarity at the behavioral level. There's also a dissimilarity at the behavioral level. Dissimilarity at the behavioral level is like, when I wake up in the morning, I have a plan. It's like, I've got stuff to do, and I try to spend my day doing it. That is not true for current language models. So current language models, they just sit there and, kind of like, if you query them, then they will respond because they're like autoregressive sequence predictors. But they don't have motivations. They don't have goals. They don't sort of intrinsically generate ideas about what they should and should not do and then seek to pursue them. But we do, and we do because we have to, because otherwise we wouldn't stay alive. So, as always, there are ways, if you wanted to make a case that neural networks and humans were totally dissimilar, there would be lots of information you could draw upon. But if you also wanted to make a case that they were similar, you equally would have, kind of like, the world's your oyster in terms of information.
I trust you've enjoyed this brief section of my conversation with my most excellent guest. Check out the full podcast episode by clicking here.